Hi everyone, my name is Xupeng Zhu. Today I'm excited to present my recent work, EquAct, an SE3 equivariant multitask transformer for 3D robotic manipulation. It's a joint work with Yu Qi, Yizhe Zhu, Robin Waters, and Robert Platt. For background introduction, a multitask keyframe policy usually takes as input an point cloud observation, a natural language instruction, and predicts the keyframe action, which specifies the next best to go gripper pose in SE3. This formulation enables to build a multitask transformer to solve various tasks. Nevertheless, the transformer architecture that usually tokenize the language input as well as the point cloud input will break the rich geometry in the tasks. This will result in a poor 3D generalization and a low sample efficiency. So the core idea is to leverage the equivariance and the invariance. For example, this task requires to pick the moon block. The optimal action is highlighted in red. Now if we rotated the observation by 90 degrees, then the optimal action should be rotated as well. So this reflects that the mapping between observation and action are 3D equivariant. Additionally, we find that the transformation of the action only depends on the transformation of the scene of the image. Therefore, the language should stay invariant. So to enforce such equivariance and invariance, we leverage the spherical Fourier representation, which is a spherical signal in the latent dimension of the transformer. So we use the spherical harmonics to transform it into Fourier coefficients. And this process is famously known as a forward spherical Fourier transform. And this process could be reversed. So the Fourier coefficients provide us the benefit for compact yet super expressive representation. For an overview, EquAct first take as input the language instruction and the point cloud observation, and then using a point cloud transformer to encode it into a latent spherical feature. And then we predict the translation and gripper open action through a coarse to fine scheme. Then EquAct predict the rotation action, which is a Q distribution over SO3. We achieve this through spherical convolution. And lastly, we execute the action through a motion planner. Now let's focus on the point cloud encoder. So EquAct proposed a novel and approvable SE3 equivariant point transformer unit, which consists of multiple down convolution layer and multiple up convolution layer. So here the gray block is a standard multi-layer perception block, and this light yellow block are standard equiformer V2 block. Here the darker yellow block is an SE3 invariant film layer to enable invariant language condition, and this shallow blue block corresponds to a spherical Fourier max pooling layer that can reduce the spatial dimension of point cloud. Lastly, we propose this novel cyan block, the spherical Fourier upsampling layer that restores the spatial resolution of point cloud. So this is the overview. Now, during training, EquAct tries to maximize the expert action using cross entropy loss. Essentially, it predicts the expert's translation, rotation, and open actions. During inference, we simply select the action with the maximum expert probability. So we evaluate EquAct in simulation RL bench tasks with 18 tasks and 249 language instructions. These tasks consist of precise tasks requiring precision, like rotation and using tool and the contact reach, etc. Like this is in the clutter scenario. Notice that all of these tasks can be done using a single transformer backbone. For summary, EquAct achieved state-of-the-art performance across 3 variations, including SE3 variation trained with 10 demo, SE2 variation trained with 10 demo, and SE2 randomization trained with 100 demo. We further performed a physical robot experiment. Here is to disassemble the pipe, while the pipe is SE3 randomly clamped on the workspace. And this task, EquAct is prompted to pluck the bottom flower. Notice that the branch is randomly located in the workspace with random SE3 poses. Here, EquAct is prompted to pick up the peach. The fruit is SE2 randomized. And lastly, EquAct was prompted to install the big toilet roll. Notice that the pack was SE3 randomized in the workspace. Our method on average outperformed the 3D diffuser actor by a large margin in the real-world robot experiments. We additionally tested the robustness to destructors. We find that EquAct can still perform this task despite that there are 10 random objects placed in the workspace. So for summary, EquAct leverages SE3 invariance and equivariance in the observation and the language to action mapping, achieved strong 3D generalization and high sample efficiency. The limitation is that the keyframe formulation could break for fine-grained manipulation tasks. We open source our code in this link, and thank you for your watching.